Hi everyone. I'm Kirill from Nethermind. Today I'm going to give a workshop on building efficient agents. It's not tied to any framework, just a workshop related to the practices that help people build agents that works reliably, effectively, efficiently, and which are easier to debug. And the practices are usually makes life easier. So we see a lot of frameworks in the space, and there is interesting thing that most of successful LLM-based agents are actually relying on really simple composable patterns, but not on the sophisticated frameworks. So there are 3 lessons that we will be exploring, and I will conclude in the beginning. First is that overly complex frameworks often introduce the hidden complications and actually makes harder to debug the code. So first, if you have ever used ELIZA or other frameworks which gives a lot of capabilities from the beginning, it's usually easy to start with and build something that looks that it works. But then when you start using it in the reality with the real data, you start having issues and you actually have not a lot of ideas how to debug it. So this is the first problem. Then usually it's better for the long-term success, it's better to start with minimal building blocks, and which allows you to easier debug and faster getting through the iterations and getting your product better. And the third thing is that in the long term, also keeping it simple and measure results helps you keep your product better, reliable, and easier to actually make better. And you better add the complexity only when necessary. So when you analyze the problem, you check the metrics, and you decide whether you should add something or not. And first of all, there is a small differences between what we call agents and what we call workflows. So with workflows, we use LLMs and tools and specific data sources, but the workflow is predefined. So the sequence of the steps is predefined in the code. And with the agents, we allow LLMs dynamically decide which route to use, which tools to use, and which data to use. So the key distinction is that agent is maintaining control over their steps, and in workflows, you follow fixed steps. And there is also a question when to use and when to not use agents. So it may be obvious that agents are powerful and you have to use them where you can, but in the real world, if you can resolve the problem without involving the agents to plan and to control over the steps, you actually get into the something working much faster and in much more reliable way. So simplicity first, you should rather try the workflow and check whether you are satisfied or actually need these agentic capabilities. But with agentic capabilities, you have to check that and you have to consider and assume that the cost will increase, because each LLM iteration, which you will have a lot, will cost something and also introduce latency, and the debugging will be harder. So with workflows, they fit into well-defined tasks needed consistent results. And with agents, if you assume that your task is open-ended and it's hard to predict what is needed for the user, then you have to use agents. So there is a funny example how people could use agents for actually checking the class if the description fits to the class, but let's just skip it because you cannot see the bottom of this slide. Using frameworks, pros and cons. There are a lot of frameworks in the space, and some of them are useful as examples, some of them are useful to make some quick demo. But as I said, they most you start with something which seems to be working, and then you try to make it better, or you try to use it in different scenarios, and you realize that it starts failing. And it's really hard to debug using the predefined frameworks, because the complexity and the problems that usually occur, they are somewhere inside of these frameworks. So you don't even see the full prompts, and you don't know what's happening in your agent. So there will be a few patterns shown related to workflows and something related to the agents. So in the beginning, I would say that we assume that the main building block for each basically pattern is the augmented LLM, which means that we are never using LLM to extract any knowledge. We assume that the LLM is some kind of a processor for the data that we are intentionally giving to the LLM, or the tools that we are giving to the LLM. And also we are carefully maintaining the context that LLM is using. Without it, we can get much more problems and hallucinations and unreliability. So the first workflow is just prompt chaining. It's the most obvious thing. You break the task into the steps. For instance, if you even can resolve the task with one prompt, but it actually can be decomposed into few steps, usually it's better to decompose it into these steps, because you can figure out that in some cases you cannot actually debug and make LLM work. But if you can decompose it into a few steps, then you can figure out at which step the problem is occurring, and you can even substitute one LLM by another, or you can tune the prompt on this specific stage, and then make the system more reliable. But also you have the opportunity to optimize your system in terms of the cost efficiency or latency, because you can use, for instance, smaller LLMs or more specific LLMs. And for each workflow, we'll have a simple example that I will quickly go through, because we have not a lot of time, but you'll be able to access this deck after the workshop. I will share it in the chat. So the prompt chaining example is really simple, and I can scroll it. So in this example, we have call GPT function, which is just a call of ChatGPT. It can be any model or any other LLM provider. And there is an example which is related to the simple function of creating a text on the topic in some specific language. So we don't write here one prompt like write this topic in this language. We break down it into two calls of GPT-4. So at first step, we see that write a short marketing copy about the prompt, put the topic here. Then we even have the gate, which is checking, like kind of validating the output. And if there is an error occurring, we can raise it, or we can make the error processing. And then we have a separate step for translation with a prompt translate to target language, and we're putting here the context. So this is an example of this workflow. It's kind of seem to be obvious, and let's go further to not spend a lot of time. So the second workflow is routing. And I will just give a small analogy, these patterns are similar to the patterns of programming in normal programming language. So if you know how to use them, you can make the architecture of your system make it reliable, assuming that these are the building blocks that you can use in this or that pattern, and you can think which one is better fitting to your particular problem, and you can use them, and you can also combine them together. So in routing, their goal is to classify the example. We can have a problem where we need to classify the incoming messages, and then according to this classification to decide which LLM to use. So again, we are not putting everything into one prompt, so writing in the prompt like if the request is related to this, then do that, and then. We are breaking it down into the few different steps, and we are doing this. Actually, we are choosing in each input request and choosing the model, or it can be actually an agent, or it can be a human, whatever, and then it makes available the effective and reliable and more accurate approach to the results. So we can measure each flow separately, we can have a data set, test set, etc., and we can optimize each part separately. So as an example, this example with customer queries, so we'll start with the end part. So the queries as an input, and the task is to process them separately. So we have the function root customer query. We go to this function and we see that there is one classification prompt, classify as, and show 3 categories. This query substituted and answer with 1 word only. So don't do this, use structured output, but this is an illustration. And then there are 3 categories. So we call GPT first to get this category, and then we run the second call with the query and with the particular handler, what to do with this request. So instead of this simple prompt on the second part, there can be some specialized model or agent or some prompt with access to some specific data or some specific functions, anything. You can combine it in any way. Next type of workflow is parallelization. It's a different thing. It's actually helpful when you have some time-sensitive tasks, so the delay means a lot for you, for instance, or you need to do some different actions on the same input data. So there are two types of parallelization. One is sectioning, when you have one large task and you can actually separate it to the parallel set of tasks that don't have any relations between each other, that have to you to wait for the end of one task and then run another one, so you can parallelize it. And voting is another type when you can run the same prompt multiple times and you get, for instance, different responses that you can combine to get more reliable output. And here's an example for this. This is example with the code review task. So in here we have sample code, and we run this parallel code review. And in this particular task, we have 3 different tasks for review: security, performance, and style. So we run in parallel all 3 tasks. So you can see it here, and we run it via Syncio library, and they run in parallel. You get the results, and you can print the results after. The fourth type of workflow is orchestrator and workers. And again, it's a different thing. In this scenario, we assume that if we cannot actually predict how many how many executors we actually need, and what will be the data for this executor. So because it's actually related to the data, to the input of the user, Here, it can be also described as a concept of manager LLM that delegates tasks to different workers based on the evolving needs, like based on any input. So the subtasks are determined dynamically, not pre-decided. So, and here is an example. You can see it. Let's start from the end. So in this task, we have like add input validation and error handling to all functions, and we have files as functions, two functions, so it can be 3, 4, like files number, and the task can be any also applied to these files. So we run this orchestration code update function with task and files, and let's go to the code. And in this code, we see that first we create a step for orchestration that creates a plan for this execution, but it's still actually predefined, despite the fact that it's quite flexible. So on the first step, we write the plan prompt. We say like, there's a task, there are files available, we put the list of files, create a plan for the file changes, respond in the JSON format. And then we get this, we run this for the first time, call GPT, then we have this plan, and after that we break it down to the cycle, and we apply this each task for each relevant file, and we have the result. And then we collect all of them in the cycle, so and we also run it in parallel, and we have the results done. The next workflow is evaluator optimizer, and this is the workflow that can be actually powerful if it's applicable for your particular task. In here we have the one LLM is trying to resolve the problem, and the other LLM with the other prompt is trying to criticize the solution and provide the feedback for it. And then the first LLM with another prompt with the feedback section can try to generate the better solution. So it sees the result, it sees the feedback, and tries to improve it. And this pattern can actually work well if you have some good metric of the quality of the result. And the example for the illustration is not actually related to the topic, but it can be still illustrative. In this case, what we have as a problem. So this is translation improvement workflow. So we have a text as an input, we have the target language, and we said that max iteration is 3 to not get into the infinite loop. And what do we do here in this function? So we run, for the first time, we run translation to this language. So we say translate to this target language, this text, and we have the output. And then we run the for loop for 3 iterations. And for the first iteration, we run the first we run the evaluator, and we say evaluate this translation. Here is the original text. Here is the translation that we got. And then we say if it's perfect, just say perfect. Otherwise, explain what to improve. And after that, like if it's perfect, we just break this loop. But if not, we are creating a new generator prompt where we say improve this translation based on the feedback. Here is a text. So 3 inputs: the text, the current translation, and the feedback that we have gotten from the evaluator. And then it goes to the loop, and the result can be actually better than one straightforward run. And the next workflow is this is the true autonomous execution agent. And the features here is that, as I said, LLM decides on its own the steps and tools that it calls in a continuous loop. So there is kind of minimal or no human oversight. And when we need it, if the task is something multi-step or long-term, long-form, something that we cannot easily plan in advance. So we assume that planning is the thing that we have to actually do via the LLM. And we actually, if we do this, we have to think about how we will process any problem during these steps. So if it fails in each step, what it has to do to not fail the entire problem, and also you have to assume that the fail can occur and on the step that you didn't expect that it will happen. So because the steps are generated. So how the code would look like for this particular example. This is the most sophisticated compared to other ones, and I even ran it and created the outputs to see how it worked. But first, let's look at the code. So we have here the class of this agent, and we define three tools by a dictionary. There is one tool, search docs, like to search for some documentation. There is a tool, calculate, which is actually the evaluation of the expression, mathematical expression, and the write file. It's something where the agent is supposed to write the output. And we also create the description for each tool, which is important because without this context, the agent will not understand what's happening. So, for instance, search docs is a tool, and we say that available arguments are, and we even describe in plain text which are available arguments, pricing and features. So we could describe it in some programming language like format, or in any other type of description that is actually as clear as possible, because agent has nothing besides what you gave it. For the calculate, we say that the argument should be a numerical expression that will be executed as eval in Python interpreter, returns the output. And for the write file, the argument should be the text to be written in the file. So I have just said that this agent will have some tools with some descriptions, but I didn't explain what task it's supposed to resolve. So let's check first how these functions are described, then we will get to the task itself, and then we'll get back to the steps, how the functions that are actually describing how the agent works, the logic of the agent. So for search docs, we have, as we described, we have just two input options, pricing and features. As you can see, there's some simple error processing, and agent can actually process this. But as this is an illustrative example, you can see that for pricing, it just this function responds: basic plan $10 per month, pro plan $20 per month. That's it. And for features, if an agent decides to ask for features information, documentations, it answers features, AI chat, file storage, API search. That's it. For calculate, this is the actual eval of the expression that agent is sending to this function. And for write file, we put it as an not the actual mock function, we just print the successfully wrote if it did. And then let's look at the function, the task that we're trying to resolve. So the task can be actually in arbitrary manner, described in an arbitrary manner. So you can imagine a person which knows nothing about the system that they are interacting with, and they are asking for something that this system is supposed to do to be capable of. For instance, if we know that there is some information, I don't know, chatbot related to some system support or something like that, so we can ask it, or analytics, we can ask it, create a pricing summary. First, search for pricing information. Second, calculate yearly cost for basic plan. And third, write a summary to a file. No details regarding how it's arranged inside. Like I don't know anything. And what the agent is supposed to do. So to do so, we have. Let's go first to the function that we are actually calling solve task. This is it. So it gets the task, and what it does. So main agent loop. We create the context, which is empty in the beginning. We create result, also empty list at the beginning, and we start from the step 0. And while true, we run the first. We don't know what to do, so we run the function called getNextAction. And just to highlight the entire way, so that there are only 2 actually important steps. So first we ask for the next action. Then we just check whether the task is complete or not, and then after that we execute this action. After we figured out what the next action is and executed this action, we put the outputs into the context with the key, with specifying the number of steps, and we append the results. So we're just keeping the context between the steps, and that's it. And now let's check what's inside of the get next action and execute action. With execute action, let's start with get next action. So in get next action, we remember that we have the task as an input, we have the context which is empty in the beginning, and what we have in the prompt. So the prompt is arranged the following way. The task is, and we put here the task, then we always show to the agent all available tools, and we put here actually the descriptions. Descriptions contain everything that is needed. Then we put the context, which will be accumulating between the steps. So we have an empty context in the beginning on the first step, but we know that the context will be accumulating. And then we say, determine the next action to take based on the current context and available tools. Previous results can be referenced using result X. So it shows, it explains how to read the context, because the context is the place where we keep the results in a way of logs, like result 1, and we put here the result of first one, result second, and so on. So the agent on each step knows what was on all the previous steps, and is able to figure out what the next step should be relevant for this. And we ask to respond in the format like tool name, because we know we need to figure out which tool to use, and we ask for the argument, so it creates arguments on the fly, or we ask to say task complete if it's complete. And then we actually run this and get the next action in JSON as we asked. So we should actually do the error processing potentially if it fails, but in this example we don't have this. And after that, as I said, we go to the execute action, and the execute action, we have the action that we have just gotten, and we throw here the context, which is important, and what we have, if action tool task complete, then we just go to the exit, and if not, we try to grab this tool from the available tools. And if no tool, we say this as a result, we actually say to the LLM, tool is not found. And we actually can expect that LLM on the next step will figure out, oh, I called something wrong, it doesn't exist actually. And then if the tool exists, then we just call this tool with these inputs and get to the output. So finally, let's see that how it works. With this particular task. This is the logs of the real execution. So starting with the task, so here is the task that I asked. What we see on the first step, it says plant action, tool, search docs. It decided to choose the search docs by itself. Then it got the result, basic plan 10, pro plan 20. Then we see the next action. With next action is calculate. And we see that the argument is 10 multiplied by 12. So we understand that 12 is 12 months in a year, and it intentionally took the 10 from the appropriate basic plan because we asked for the basic plan. Then the next action, it got the result 120 because it's executed via eval, and then we see that it choose to write file and put it into the output, and then we see the result successfully wrote, so planned action task complete, and that's it. So it works this way. It's quite flexible, and it shows how to use the tools and sources and functions. So here is a small example of how the coding agent works, much more sophisticated than we just described, and there is also environment. As a conclusion, again, start with simpler blocks if you want to build something reliable. Always measure performance when you try to add something complex, because you have to figure out if you need this or it actually make it less reliable. And every time to expand only when needed. So that's it. The time is up. I will share this presentation in these chats of projects that I shared on the previous talk. And if there is an opportunity to get any questions, we'd be happy to answer. All right. Thank you.